started UG course in Cooch Behar district under North Bengal University in the year of 1991, and in the year of 2017 under Cooch Behar Panchayat Brahma University, our department also started PG course, and at the same time, our department also started one certificate and diploma course on geoinformatics. So at present, our department is a very common and famous department in this district. And today, our main topic is remote sensing of atmosphere, of ambient atmosphere, concept and application. In today's ultra-modern society, we really develop so much in concepts of all-round development. At the same time, we have some environmental problems or environmental feedback, where we, sometime we started our society modern to modernize in this way. Sometime environment gives some feedback to us that sometimes we face various types of problems, environmental pollution. So yeah, air pollution is the most dangerous types of pollution in environmental pollution. So today's lecture on based upon ambient atmosphere, especially the remote sensing of ambient atmosphere, its concept and application. So I would like to start our resource person, especially actually our in college today TC election is there, so that's why principal is not there at that time. But uh, after a few minutes, when principal sir will join, we will call to principal sir. But now we are not waste time, so I like to start our resource persons, Professor Biplab Biswas, to start today's special lecture. So, Biplab sir, please start today's lecture. Sorry, sir. Sorry, sir. Understand.
Okay, thank you so much, Keshav, Dr. Keshav Mondal, and
Yes, sir.
I
Yes, sir.
really appreciate your effort to organize this conference, this webinar, and
Hey, Dashi.
and I really appreciate your team and your principal, sir, for giving you the permission to organize this webinar. And I'm fortunate, really, I'm fortunate enough to be here in this webinar. And of course, I would like to say big thanks to your organizing team, Dr. Tapan Kumar Das, Srimati Sonel Som, and the other members of your organizing committee, and the chairman of this webinar is your principal, sir, Dr. Pankaj Kumar Debnath. So I really appreciate all of you in giving me the chance to say a few of my research activities before this good gathering. It's 90 people that there in this currently on the screen is a big thing, huge thing, and and I'm really happy, Keshav, to you because for you, I did lot of research, a lot. Maybe this new field I could explore a lot of things, um, and I could learn myself a lot of things. Maybe I was trying to do this type of studies since say last few years, and finally through your lecture, this is the first lecture I'm delivering on this topic, and maybe first of this kind uh, in my all the lectures. I have so many lectures in different institutes, across India. But this lecture, this topic on remote sensing of the ambient air is very new, new concept and the latest development in the remote sensing field. So it's a challenge to me, and so it's a post-lunch session. Uh, Maybe many of us, feeling sleepy after heavy lunch and in the Saturday afternoon. Okay, so I think uh, I will try my level best to keep you awake, and
Uh,
maybe at the
Sorry,
end
Biplab sir.
we will.
I'm interrupting you because sir, our principal sir is just uh, mm, join the meeting. So I request our principal sir to tell us something about our special lectures. Our principal sir. Sir, are you listening? Sir, principal sir. Hello, principal sir. Hello, sir. Are you able to listening my voice? Hello, principal sir. Okay, sorry, Biplab sir, you continue. When the site is available, I again interrupt you. So, sir, please continue. Sorry, sir. Biplab sir, please continue. Oh, sorry, sir. Sir is, yes, sir. Principal sir, I think you are audible. Hello, principal sir. Oh, sorry, sir. Sir, again, I think left the meeting. So, Biplab sir, please, sir, start. Sorry, sir. Biplab sir, please start.
Okay. Okay.
You see, you share your screen, sir.
Okay. Thank you again. And I'm just not. It is already 3:20, more than 20. So 20 minutes late we are.
Yes, sir.
Okay. So the topic of my discussion is remote sensing of ambient atmosphere, the concept and applications. And maybe I have organized today's lecture. This presentation in four segments, major segments. Maybe I will discuss a little about, very briefly, about the concept of remote sensing, and I'll say the few of the applications of remote sensing in ambient air monitoring. And there is a satellite called Sentinel 5P. I will say very briefly all the discussion, because it is only 1 hour lecture, so it's not very easy to cover in detail, but I will try. I will give my best to cover in the fourth of segment about the application of this remote sensing technique in evaluating the air quality. And I will present a case of, say, air pollution during Diwali or Deepavali. So what happens, it's a long noise every year that Diwali brings pollution, and the people should avoid firecrackers and other things. So maybe we shall explore, we shall examine through this remote sensing technique how much pollution this Diwali brings to the air, ambient air. Ambient is what, that is the word maybe. Okay, so if anybody, in the audience, will go like a workshop mode, not like a presentation, like lecture mode, maybe this is webinar, but it is much easier for interaction. So if you have any doubt, any questions, you can raise your hand. So I will stop there and I will try to address your query. So the ambient, the word ambient is very interesting. So the ambient means outdoor, So there are two types of atmosphere. Maybe you understand. The participants will appreciate that. So the say when we are cooking in the kitchen, so all the fries and other thing create some specific smell and aroma and all many things. So the atmosphere of the kitchen is different from our bedroom or our living room. So when a guests come now, before coming we organize our living room, we spray, we use perfume and other thing to make the environment very nice, very good and smelly, and I mean, so and aromatic. So like that. So that is indoor kind of environment. So when we are inside the home, it is called indoor, and if we step out of our home, it is called ambient or outdoor. And very interesting, 75% of our entire lifetime, even more, maybe 75% of our entire lifetime, we stays indoor. So keeping the indoor environment clean is much more important than cleaning the ambient environment. Of course, ambient environment affects the indoor, but indoor is also important. So with these few words, I will go directly to my presentation scheme, that is concept of remote sensing. Okay, so very briefly, we understand, most of us who are joined here, who are present here, know, the term, have heard the term remote sensing. And of course, it is a science. Of course, some people say arts. I don't believe how it is arts, but it is a science, fully science, of obtaining the physical properties of an object, of an area, of an feature, you know, without being, without personally being present at that particular point or at that particular feature. So just obtaining information about something from a distance, using some technology, using some devices, using some techniques. The whole process is called remote sensing. The whole process. It's not a single component. It's not a single. So if you have a single instrument, you cannot say it remote sensing. So it's a combination of a lot of instruments, a lot of processes, and say science involved behind, say recording the data, processing the data, analyzing the data, and obtaining or getting the information about the features. So it's a long, complex but beautiful scientific process. So what it does, remote sensing captures the information, it can visualize the information, and of course it can analyze the object and the features on the earth's surface. Mind it, what I said is earth surface. So this is very typical conventional definition, that by remote sensing, we get information on earth's surface, so that is very interesting, maybe, but today we are going to discuss this ambient air. So here is the twist. So we can have information above the earth's surface also. So today I will discuss that thing. So this definition of remote sensing will have another component in its favor, that we can have, we can have information surface, as well as. So today is the plan, and maybe in short, this is a beautiful diagram of remote sensing that near the surface or above the surface, it is written 500 kilometer, but it extends up to 30,000 or 35,000 kilometers. So what it does, so we may have balloons, weather balloons or other kind of say balloons. So inside the balloon, we can keep the instrument of or simply a camera kind of instrument, which takes the picture towards the Earth's surface. And some balloons may be little higher above the troposphere, that is maybe stratospheric balloon. So it is so light, it can penetrate the tropopause limit, and it can go up to uh, stratosphere. So from the stratosphere also it can take photographs, and it can take photographs or sense the remotely can sense the Earth's surface and its features. And second oldest, maybe balloon is the first generation, but still it is being used, and second development of in remote sensing field is these air-based instruments or airborne instruments, and I mean installed in aircraft. কিছু বলবে মনে হয়? Somebody is raising hand. Okay, so this airborne, aircraft is very useful. And earlier, the remote sensing was mostly based on this airborne. So since 1924, this air-based remote sensing started, and it lasted up to say 1990, very strongly, and still it is there. Of course, like maybe you may have seen that our prime minister or our chief minister or any other ministers visit the uh, disaster, I mean after a disaster, some minister visits the area, so using helicopter or aeroplane. So that is also of course a kind of remote sensing of the flooded area or affected area. So airborne instrument is very old one, but still valid. And of course, these are the post 1990s development, the satellites and the sensors. It stays around 750 kilometer above the Earth's surface and continuously monitoring or looking at the surface, at the Earth's surface towards the Earth, and taking the data, taking the images of the Earth's surfaces, surface features, and sending the data towards the Earth stations sitting somewhere here, Earth stations, and these Earth stations process the data and send it back. I mean, send the data to our computers, to the internet, to the server, and we can fetch the data, we can get the data from this. And these are the latest, instruments, UAVs. Normally we call them drone. So using these drone or UAVs, unmanned aerial vehicles, so we are now taking a lot of data, and these are also playing very important role in collecting remote sensing data about the Earth's surface. Okay, so these are the primary concept of remote sensing. So we can have balloon based, we can have air based, we can have drone based, we can have space based or satellite based remote sensing. And if I say 95 or more than that, maybe, remote sensing follow this particular principle. This is the principle of remote sensing. How it does, this is the sun, of course, everyone can understand from the figure. অনেকে হাত উঠাচ্ছ, কি ব্যাপার বলো, কিছু জিজ্ঞাসা আছে? You can see some people are raising their hands,
Yes,
like
Robiul
Rajibul
Islam.
Islam at this moment.
Rajibul Islam. Is there any query? Sir, you solved the query now or after completing your lecture?
Okay, is raising hand maybe some live questions maybe you would like to ask.
Yes,
Okay,
Rajibul
so
Islam.
if you cannot see,
No, sir, no, sir.
you can put question in the chat box also. Okay, so the sun is the ultimate source of energy of all remote sensing. So what it does, the sun sends the energy. It is called light, but normally we understand light as an as energy. But light is not only energy. There are more than that. In terms of energy. So we call it EMR. So electromagnetic radiation. So sun is sending continuously this radiation uh, towards Earth, and it's hit the Earth's surface and illuminates us. We call it light. And a very small portion of the light, you see, if this entire is the range of this electromagnetic spectrum or the energy from the sun, we can see very small part. This small part is only the visible portion, very small part, I mean negligible part we can see. For example, like temperature. So along with the sun, we get the temperature, you know. Um, so but we cannot see the temperature, we can understand it, we can sense it, but we cannot see it, it is not visible to us. So the question is, some amount of energy we can sense, some amount of energy we can see, it is visible, but most of the energy component neither we can visualize or nor we can sense even. So for example, if there is infrared, or microwave, none of this energy, these energies we can sense, or we can visualize. So a lot of energy is remain invisible, or I mean we cannot sense. So all this energy, it interacts with all the features present over the Earth's surface. Maybe it land, maybe it vegetation, maybe it water. So in terms of vegetation, we can say that is say tree, or say cropland. Even if it is cropland, there may be wheat, there may be rice. If it is tree, there may be mango tree, there may be devdaru tree, there may be many other kinds of. So every individual features on the earth's surface behaves distinctively, as like all of us are distinct in our character, distinct in our look, distinct in our behavior. So similarly, all the features on the earth's surface are very much distinct, so no two features, no two different features are having similar characteristics. So this classification or understanding of this behavior, of this property, we can understand by analyzing the remote sensing images. So very intensive training and understanding of this data is very important, that how this energy hit the earth's surface and interact here, and returns back and to the space. And what we did, we kept a satellite, sitting at the some elevation from the earth's surface, and that instrument records the reflected energy, radiated energy, scattered energy. Three terms I'm saying: reflection, radiation, and scatter. Three different way the energy, I mean the solar energy, that hit the earth's surface, it goes back to the satellite. So, and satellite records all this data, and it sends back the data to the earth's surface, to some computer in the earth station. So this is the one kind of, say, remote sensing. So this is, we can say, when the sensing technology, remote sensing technology using sun, as a source of energy, we call them passive remote sensing. We call them passive remote sensing. But some satellites are there. This is very interesting. Today's whole discussion is on this particular satellite system, remote sensing system. Some satellites are there sitting in the space, maybe 700 kilometers. Some are getting 700 kilometers, around 750, 800 maximum. And some are maybe sitting at 36,000, 35,000 kilometers, okay, above the Earth's surface. So they are very unique. You know, these type of satellites are very unique. What they do, they have their own energy, like the camera, I mean flashlight of our mobile camera. So in dark we use the flash camera to eliminate the object to take its picture. So in daytime we do not use the flashlight because the sunlight is okay, it's sufficient to illuminate the object and we can take the picture. But in night time, dark night, we use the flash camera. Flash is if you use the flash, it is called active sensor. So your camera turns to active sensor. So like following the similar principle, the satellites send their signals, send their energy towards Earth. It hits everything on the Earth. Everything means it hits or energizes the this way they can record. This way they can record, or they can yes, of course they can record the amount of energy sending by the sensor and received by the sensors, and may compute the soil, water, vegetation type, elevation of the land, and even the atmospheric characteristics. How much, what is the height of the tropopause, what is the content of other components of the air. So this is a really important remote sensing process, the active remote sensing. Okay, so this image, this you will be surprised. This is really surprising to me, that this is the Earth, and the distance from Earth to this point is about 36,000 kilometers, and this is height above the equator. So above the equator, these many satellites at this moment are operating, are live. They are live at this moment above 36,000 kilometers above the equator. So these satellites, which are situated about 36,000 kilometers, then they are fixed to certain point on the Earth. Specific point, latitude longitude junction, it is focused on that particular point, or the nadir point is a point. So, and when the Earth is rotating from east to west, all the satellites are rotating like this. So it is constant. The look from the satellite to this point is constant. This type of satellite is called geosynchronous satellites. So it is synchronized with the orbit, with the revolution of Earth, the spinning of Earth. So they are also rotating along with the Earth, like fixed. These are fixed satellites, but we know a lot more numbers of satellites are orbiting from North Pole to South Pole, like this, North Pole to South Pole, and those satellites are called polar satellites, or we can say them Biswas satellites. Okay, so and yes, so in a brief, what we understand is sun is a source of energy. It is sending the radiation bypassing the cloud. So that radiation, if it hits the cloud, it will go back. So like a few days we are not getting sunlight properly here in Kolkata because of thick cloud. So, and of course during monsoon season we do not get sunlight due to cloud, or even when there is a thunderstorm, or when there is cyclone, we do not get sunlight because the sky is full of cloud, 100% cloud. So all the time, even in the driest month, we get cloud in the sky, but the radiation can pass through the gap of these clouds, and it hit the earth's surface, and some amount of energy is reflected back, some interacts with the features, and this is called terrestrial radiation. All this reflection and radiation goes to space segment, that is the satellites, and it can sense. There are many sensors, there are many different sensors to receive the deflection, radiation, scattering, and of course you can see some sensors are there, those are acting as a source of energy. It is sending the artificial radiation or energy towards the earth, and it is acting on the earth surface features and going back to the sensor. So all these space segments can receive sunlight or its own radiation, and after that what it does, it sends the data to the ground segment, and the office it is there. For example, in India, in Hyderabad, Sadhnagar is the city or the town where this ground station is located. So all the Indian satellites are sending their data to this Sadhnagar ground station, and at Sadhnagar station they are processing the data and sending the data to NRSC or any other space agencies of government of India. And so what we do, we plan and we do plan and operations of satellites and sensors, and also we do receive the data, we process the data, and we analyze the data for understanding the earth's surface features as well as the atmosphere. So basically you can understand thousands of satellites are there, maybe more than thousands, satellites are there orbiting earth from pole to pole or at the equator, and all the satellites have the same principle. They scan the earth's surface, and the atmosphere with their camera, with their sensors, and they store the data in layers. They store the data in layers. So the number of layers, the more the number of layers, more specific or classification, further fine tuning, we can say, it is there. So 3 is the minimum number of slice, or maybe some satellites, of course Indian satellites have 4 layers of information they collect, and we can see these 3 layers together as a color composite, or we can see a single layer as a mono or black and white kind of images. And after analyzing the image, we can classify temperature of the Earth's surface, cyclone, land use, land cover, and every possible features on the Earth's surface. So I mean, today, nowadays, everything, even population is also being monitored. Maybe you have experienced while traveling by car, which portion of the road has got congestion. So it is visible well ahead in your mobile. So I mean, we are also being monitored by the satellite system. So human population, maybe in some other lecture, I will show how do they capture the population density and how do they count the population. So that is also possible nowadays using remote sensing. So beautiful technology, and we cannot say escape from this technology. And this is the future of geography. Maybe still some geographers are reluctant to use the remote sensing. Still the geographers are, many geographers are there who do not believe in remote sensing and the process, but this is the future. If you do not believe, the subject will say goodbye. Like, okay, so you see, as I said, there are many satellites, many satellites. So these IRS is Indian satellites. Landsat 7, 8, these are USA, made by USA. And the Sentinel, there are many Sentinels satellites. The Sentinel series of satellites are made by European Union. So the Europe, especially the Western Europe, Britain, Germany, Netherlands, they have even the smallest country, what is called Norway. They have developed this satellite system, Sentinel system, Sentinel 1, 2, 3, Sentinel 5. There are many satellites. So they have different specific characteristics, and band characteristics, as I said, IRS list 3 have only 4 layers of information. They collect 4 layers of information. So these 4 layers, we can say them in terms of remote sensing band. While Landsat 7, there are 8 layers of information. Landsat 8, the newly launched, recently they have launched Landsat 9. I should have put the Landsat 9 characteristics. So maybe in the next slide, next time when I do a lecture on this, I will add Landsat 9. Recently, Landsat 9 is in orbit. So this Landsat 8 has got 11 bands, and while in Sentinel 2, it has 13 bands. Of course, you can see 12 here, but you can see 8A and 8, 2 bands are there. So in total, there are 13 bands. So more number of bands means more information, finer tuning, finer tuning. So better accuracy in assessing the object and the characteristics of the object. So Sentinel-2 data is very useful. And yeah, most of the current remote sensing task nowadays is being done using the remote sensing data, and it had more advantage like here. So it has 10-meter resolution, where in case of our Indian satellite, it is 24-meter resolution. So in terms of spatial resolution, Landsat Sentinel 2 data, in terms of spectral, this is spectral, this is called spectral resolution, number of band, in terms of spectral resolution, that is also better. Even temporal resolution, you see, it has 24 days revisit capacity, while Sentinel 2 has only 12 days revisit capacity. So temporal, in every aspect, Sentinel 2 data is much better. In even data accessibility, if you want to use the IRS data, still there are a lot of restrictions in downloading the Sentinel, downloading our IRS data, but there is no restrictions in downloading Landsat Sentinel data. So even the current possible date, maybe today or yesterday's data, it is available in the internet by free of cost. So that's why the Sentinel-2 data has got much user friendly applications. And maybe just overlook, you can see this is Chilika Lake. So if we use the our Indian satellite IRS, there are band 2, 3, and 4. If we keep these bands in this fashion, so we can see the color composite like that. You can understand if you look at this Landsat 8, in that case we have to use band 3, 4, and 5, while band 3, 4, and 8 in Sentinel 2 gives this type of true color image of the data. So but just comparison, same Chilika Lake of Odisha, how it looks from the space by different satellite system. Okay, and yes, now this is my specific lecture today. That maybe last slide you can understand. Still, this is purely on Earth's surface features. But now, maybe in if it is in real class, conventional real field, I would have done a beautiful experiment, but in remote mode, that experiment is not possible. But anyhow, maybe you can just, if I give you an example, you will understand. So say you are sitting at a room, and on the other room some sound is there. So you can understand what is the source point of that particular sound. Maybe you are watching TV and kitchen, the pressure cooker is making the city. So you can go and put the gas off, because you can see, you can understand from where the sound is coming, because we have 2 ears, that is called stereo sound. Similarly, we have 2 eyes to have three-dimensional view. We can understand the depth of the object. I mean, how far particular object is coming from. So that's why it makes easy for us to ride a cycle or car. Otherwise, there would have been a lot of accidents if we have only one eye. So that's why we have 2 eyes. So similarly, there are so many satellites. One satellite is looking at from the top of the sky, top of a point, and another is looking the same point slightly apart, like that. Both are looking the same point from little distance with a little inclination, angular vision. So this makes the satellites possible to see the entire atmosphere. Otherwise, if just imagine, uh, I cannot explain at this moment, if you are sitting very high and looking down, it is very difficult to see, to understand the height of something, some building or tree or something, because you will find a top, you can find only the top of that object. So we need to have two view, one from the top, another from the side, to make the elevation profile, to make us understand, the depth perception. Same thing, there are many satellites which are building up three-dimensional view of the entire atmosphere, and uh, it is possible now for us to analyze the chemical composition of the air, and even the sensors are so sensitive, it can record the billion parts of any component. Very interesting. So all the gaseous components, nowadays can be monitored by this remote sensing uh, technology, by the satellites. So you can see there is a Sentinel-3. I said Sentinel-1, 2, 3. Sentinel-3, it can record the carbon content of the ocean. The carbon dioxide is being released by anthropogenic activities. As a human being, we do a lot of activities, industry or cooking or burning or something else, and that releases carbon dioxide. And ocean is the sink. I mean, it absorbs a lot of carbon dioxide. It absorbs a huge volume of carbon dioxide in it. So this Sentinel-3 satellite is specifically designed to estimate the carbon dioxide amount in the ocean, and the process. They are trying to understand the process of this sink, how this carbon dioxide is getting absorbed by the oceanic water. So that is very interesting, Sentinel-3. And we are also aware about this El Nino, La Nina, and this world's corals under threat due to this El Nino is a warming, because this is specific, say, global warming, I mean ocean warming event, and that also being monitored by the European satellite system. And of course, recently there was a volcanic eruptions. Many of us have seen that video in many media, news media, WhatsApp, Facebook, many other medias. So that volcanic eruptions and the gases released by those volcanic activities are being measured by the satellite system. Even atmospheric boundary, you can imagine, atmospheric boundary means the boundary layer between troposphere and stratosphere, that is also being monitored by the satellite system. And 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 what else? Yeah, we can measure the Earth's surface temperature. It is very interesting. Even nowadays, forest fire or any other kind of fire is being monitored by these sensors. And you can see where world's fire atlas, it is there, where there is active volcanoes, where there is fire. That means it is alive. So this, especially they do this like nighttime fire series map for last 20 years. And of course you can see the air is there, air say estimation of nitrogen dioxide, it is there. And these some of the very few, only 5, I kept only 5 only. So that is cloud top height, it is measuring the carbon dioxide, tropospheric methane, smoke, dust and smoke detection, even the snowfall amount, it is being monitored. So there are many kinds of sensors which are sensing the Earth's atmosphere. And maybe if I do not say the name of MODIS, I may be doing wrong. That MODIS is a very, very big project of NASA. And there are two satellites, twin satellites. One is Terra, another is called Aqua. This Terra and Aqua satellites, of MODIS, they monitor the entire Earth. I repeat, they monitor the entire Earth 2 times a day. The same satellite passes over my head or my home twice a day. One in morning 10:30, another is evening afternoon 3:30. So 2 times, one Terra and Aqua satellites pass over the same location, same point on the Earth, and it is monitoring a lot of data, land use, land cover, climate, aerosols, atmosphere, huge amount of data. But today I am more interested to talk about the Sentinel-5 data, type P, that is a satellite. And if I click here, what it does, it takes me to this page, that it is very specifically, this Sentinel-5P is specifically designed for monitoring the Earth's atmosphere. Okay. So this is the image. You can see the Sentinel-5P. Using the Sentinel-5P, we can measure the methane, we can measure nitrogen dioxide, we can measure carbon monoxide, sulfur dioxide, formaldehyde. Formaldehyde is artificial kind of gas, and it is purely anthropogenic activities. And we use a lot of formaldehyde, and it is carcinogenic. It causes a lot of health issues, even cancer. And of course, we are interested to know about the ozone and its thickness or the component of ozone. So all these 6 parameters, atmospheric parameters, it is being monitored by this Sentinel data, and every day it is recording the data. So the data is daily basis, the data is free for us, anyone can use the data, no restrictions at all. And no, only the login is required, of course. Login is required as like any Earth data or Sentinel data. So there is an instrument, in the Sentinel-5P, there is an instrument called TROPOMI, Tropospheric Monitoring Instrument. This TROPOMI is a beautiful instrument, and this TROPOMI is designed or co-founded by Netherlands Space Agency. But normally it is ESA, that is European Space Agency, and it has been launched on 13th October 2017. But that data is available from I think July, maybe, yeah, July 2018, not before that. So 1 year they took the data for validation and research. So after validation, they released the data from June. I forget. I'll tell you exactly. June or July. July, probably July. July 2018. And of course, the data is available from Copernicus Open Hub. So if we click on this Copernicus Open Hub, and you just do the login process, and you can do this Sentinel 5P data for your usage. So you can. It is very easy. Just you login into the atmosphere. I mean, thing, and maybe some of us are already aware about this particular window, Copernicus, and so we can browse the date, and we can say give the area of our interest, and like this we can design the area of interest, and we can do the we can download the data. Simple, very simple. So that's why I say it's open access. But our Indian system, still we do not have any satellite which can measure the atmosphere. So yes, as I said, it can measure the molecules, concentration of molecules of nitrogen dioxide, sulfur dioxide, CO, there is formaldehyde, ozone, and CH4. And yeah, we can do a lot of things, and data it is public, and anyone can download it and use it. And the spatial resolution, if I can remember it correctly, it's it depends, it depends. So maybe 10 meter you can get it, or if you require for a large area, you can reduce the resolution. So it is customized resolution. You can do your own resolution. So if you analyze the data for the entire country, you cannot analyze in 10-meter resolution, because our computer is not that much high end, but we can reduce the resolution to 200 meter or 250 meter, or even more than that or less than that. So to analyze the country level analysis. And functional Sentinel 5P, it produces the data in 3 levels. Level 0, but this is not for public, so I'm not discussing it. Level 1B, it is so when you search the data, so you can see the level. There are many, I mean, these are the gases, of course, product type, and yeah, level. So here you see level 1 and level 1B and 2. So there are many levels, but they do not provide us level 0, but level 0 data is also there. And all the data are geolocated. Interesting, you see, the atmosphere data, it is geocoded. So of course we understand the atmosphere is volatile, it moves, it has a flow, it has vertical and horizontal flow, but then also at the time of recording, it keeps the data stationary. So we can understand if the pollution is coming from Kolkata, or it is coming from Burdwan, or it is coming from any other, say if we zoom in, so what is exactly the polluting industry, we can identify. So that's why it is geocoded, beautiful data. And all the data, so maybe ozone or sulfur dioxide, anything, all the data, it is geocoded or geolocated. Okay. And most interestingly, you can see, you will appreciate definitely, the user documents, products and algorithm, the technical guide, everything it is given in this particular website, Sen 5P, and maybe yeah, you can see in the Sentinel 5P data products. So where all the products and algorithm maybe is available. Even the software, they also give the software. So this is the technical guide, you can see, and maybe this data access, and what is this? Yeah, this is the toolbox. You can download this data. I mean, toolbox means the software. You can download. You can make use of these softwares. These are softwares. for working with this data. So everything, it is open and free, you can use it. Okay, and one more data products. So whatever, if you take level 1B or 2, there are another subdivision. One is near time, NRT is near real time. That is after recording within say few hours, 2 hours or 3 hours, you can within 3 hours. Yes, within 3 hours you can get the data. So within after recording the data within 3 hours, the data is processed and made it available for public use. So today, if I want to analyze the air quality of today's Kolkata's air, just now I can do using this Sentinel 5P near real-time data. So, and offline, of course, so there is another. So we cannot, you can use this offline data. And most of the data are pre-processed, but you can process. And as I said, there are many levels, many products. It measures the ozone, total ozone, so entire up to stratosphere, within the troposphere, entire profile, same thing. All the component, total column, stratosphere and stratosphere, it distinguished. So if you are interested to only the stratospheric, tropospheric pollution, because we live in troposphere, we are more concerned about troposphere, maybe we should be as a geographer, we should be interested to use tropospheric column. And yes, maybe what is the thing? Just I am starting the case study. You can see case study just started, and what I did, maybe the fourth final part, and this is very interesting for me, and of course I think it would be interesting for you also. As I said, Diwali is celebrated in India, with crackers, lights, and other things. So we love it. We do it, but there are a lot of sounds, a lot of noises comes from various sections of the society that it causes pollution. Okay, so today my ambition, my aim is to estimate that how much air is being polluted by this, specifically on this Diwali. And I would like to compare this data. Of course, this 2017, I wrote it 2017, but it would be 2018. Okay, maybe I correct it here just a second. I can correct it here. It is not 2017. So it is 2018 to 2021. So all this 2018, 2019, 2020, 2021, 4 Diwali events. I have collected the data for your presentation. And yeah, and what I did, I considered there are 43 million plus cities. I think all of us understand what is million plus cities. So as per 2011 census, there are 43 cities in India which have population more than 1 million. So if a city contains population more than 1 million, it is called million plus cities. So there are 43 cities in India. So I have recorded, all the data for from these 43 cities, and also compared the data on all India average. So how this works? Let us explore how this works. Okay, and this is a huge data, and maybe all of us know about this Google Earth. So I have used a customized, a specific software called Google Earth Engine, and maybe if time permits, I will show how to work, because already 4:15, so I will finish by 5, because is not it, Keshav? আমাকে 5টায় বন্ধ করতে হবে তো?
না স্যার,
So
আপনার প্রবলেম নেই, ইউ ক্যান কন্টিনিউ।
So if maybe my energy level, of course, your energy level
no sir.
permits, I will show some basic things about the use of these things, how I have used this open source platform to compute this huge database. You will be surprised to see the database. So maybe that's why I kept these slides blank, So if I get some time, I will use this screen back after the lecture. So these are the 43 million plus cities. You can see this is alphabetically arranged. Of course, this is alphabetically arranged. Agra, Allahabad, Asansol in West Bengal. And in West Bengal, I think Kolkata is also there in number 23. And of course, we have the capital city, Delhi somewhere. Yeah, number 10 is Delhi, and Jamshedpur and Vijayawada. See, all these 43 cities are listed, and where they are located, you can see in the map. Yes. Okay. So this is the map. You can see 2018. Try to understand. The Diwali date was 7th November. So what I tried to do is, because many times we see, before, on the eve of the Diwali, on 6th of November, some people do also do this firecrackers or light the candles and other things. So we start celebrating basically. I have taken the 0 day is the Diwali day, and 5 day on the left side and 5 day on the right side. So from 2nd to 12th November, these 10 days average, NO2 concentration, it is mapped. So this is a mean concentration of nitrogen dioxide in this segment. Just I mean, register hote parchi na. Just it will take a few seconds. Okay, maybe. I will show. It will take a few seconds, not more than that. So consider this is the Earth engine. So just like the image, it is the Earth engine. So if I import our India, so it is our India. So if I say this is India, and I want to map the India in this image, so I can do it, and this will be you see, this will be the India will be mapped here. So the India outline has been mapped. So if I say to use this Sentinel 5P, if I say to use this Sentinel 5P, you see this Copernicus. If you zoom it, Copernicus, this is Sentinel 5P, and I have taken a date of first. No, I will reduce the date. Of course, I will reduce that date to not this one. Maybe I will not do this one. I'll try another script. So what I do, I bring it here. So what is that? That Sentinel 5P, and this is called near time image in a TI. So, and we are measuring NO2, and NO2 column number density is the density in the troposphere. This column, this band records the data in the troposphere. Okay, and maybe I would like to see the mean, median, and mode of this. Maybe I'd like to see this data first. Maybe I would like to see this data. Like, you can see, you can understand here, the black is 0, and blue is next higher, and red is the highest color of pollution. Okay, So this is the index color like that, and maybe mean. And so if I say map the Sentinel 5 atmospheric pollution in 2029, it is 29 of 22nd of October to 1st of November, and the data is in mean. As I said, I will discuss the mean. Maybe it is working. Let us see. This is very simple, and it works beautifully. And we will have the nitrogen dioxide concentration within India during this period. So just wait a second, because it takes a few seconds, because it is fetching the data from the server and directly processing the data for me. And I think the internet is little slow, but it is coming. You see, it's coming, and it is subsetting the data for me. So this is the nitrogen dioxide, average nitrogen dioxide in the atmosphere during 2019, this time period. Okay, so in this way I have collected data, and in this way I have collected data, and I have collected presenting these images for 2018, 2019, and 2020, of course 2021. And this is the index, you can understand. And you see the maximum amount of NO2 was in 2018 Diwali, and we all know there were restrictions from Green Tribunal and as well as our court, and of course we were also responsible citizen. We did not use these firecrackers in 2019 Diwali as well as 2020 Diwali. So the pollution amount was much lower, and even in 2021 we started, we did some celebration. We were hoping that we go to overcome the corona. So we celebrated the Diwali with joy, with happiness, and the result is that we have higher pollution amount, NO2 amount. And of course this is the mean, and pollution, the mean means average, this is minimum, and the standard deviation also very low. So but you can, I don't know, I have to explore further why this central part has got very high amount of, you see, normally we say Delhi is pollution, but much more pollution is here in this region. Maybe industrial mining regions may be responsible for that is NO2 pollution in the year. So these are the 4 images that I have collected from that Sentinel 5P data, and of course the impact of this COVID reduction, COVID related restrictions is very visible, very much visible of from this diagram, that in 2019 and 2020 we had much lower NO2 level. And if we say similar way, if we program for carbon dioxide, CO2, this is also as like this NO2, here also the carbon dioxide amount was really low in 2019 and 2020. And of course you see in 2019 the Eastern India has got huge amount of carbon dioxide, and while in 2020 it is Western India, in 2021 is entire our plain land, northern plain land, including our Kolkata. So everywhere the concentration of carbon dioxide was much higher comparing to the southern part of India, even with the western part of India, you can see. So maybe we need to study this behavior. But for simplicity, for keeping the lecture time in mind, I just focused on that NO2 not other components maybe, but we can do everything. I think I have another slides. No, in another presentation we can map everything as like Sentinel 5P said. Now we can map CH4 and all the components, whatever. I am not going to say it again. Similar way, we can map. We can download the data for all the atmospheric pollutants. So, like this is 2018. Let us have some further discussion on it. So this diagram, as I said, that I don't know if I have that Excel sheet open. Maybe let me check. What is this? 2018. Just let me check. This is 2018 data. This is 2018 data. So you can see in 2018, 11th of October, November, 2nd of October, 2nd October, 2nd November, right? 2nd November, 3rd November, we have that data, you know, and maybe where is the 0 day? Zero day is 2018. If I say 2018 Diwali date, 2018 Diwali date was 7th November. Okay. So 7th of November, this one. This is the 0 date, and 1, 2, 3, 4, 5. So these 5 days on the left side and 5 days on the right side. So this is the average of 5 days on the left side and 5 days on the right side. So we can clearly see there is most of the cases there is a jump in atmospheric NO2, ambient NO2, because satellite cannot go inside our home. Till now, there is no technology for the satellite to go inside our home. So the peak is definitely on the Diwali day. So this is important contribution from this satellite data, that we can clearly estimate that in most of the cases, maybe for this Nagpur it is different, but in most of the cases, this is our Kolkata. Of course, Kolkata is also different. That I don't know. Maybe we celebrate Diwali in the next day. I don't know. So the Diwali day has got lower ambient NO2 level in Kolkata than the previous or the post Diwali event. So that is 2018 Diwali case. And as you have seen, please try to remember this diagram. You know, this mean data. This is the average or mean concentration of carbon dioxide. I mean NO2, nitrogen dioxide. So if I put this mean concentration of NO2, ambient NO2, in a straight line, and these are the 43 million plus cities, and in 2018, Jamshedpur was the maximum, had the maximum amount of pollution on the Diwali day. So this is of course in decreasing order of pollution. You can understand. The middle one is Diwali 18. Middle one, the red or what is the color? So the red one is the Diwali day, and the left side is the pre-Diwali day, and this is the post Diwali day. So you can understand this type of curve is, I mean almost everywhere this type of curve is there. You understand? So so Jamshedpur has got the highest ambient NO2, and then Mumbai, Faridabad, Chennai, Nagpur. These are the top polluting cities. Delhi is coming much later, and but in terms of post Diwali pollution, it is the highest. It ranks much above the rest of the cities. Okay, and where is Kolkata? Kolkata. Yeah, here is Kolkata. Kolkata is much in much lower segment of the curve. Okay, here is Kolkata. So it is very close to national average, but none of the cities, most important, none of the cities, this average is, considering the whole India, pan India. It's not only the cities average, it is pan India's average. So considering rural part and urban part, everywhere. So this straight line, it goes almost, not almost, every city, all the cities are above the national average level. So we can, in single line, we can say all the cities are having higher amount of ambient NO2 level during Diwali in 2018. Okay. And if I go to this diagram, that is, if I do some further statistical analysis of the difference between post and pre-Diwali ambient NO2 level. So this is the unit mole per square meter. So you can see only in Jamshedpur there is a negative change. Few of the cities, very few of the cities have negative change. That is, it has less pollution than the pre-Diwali date. But in most of the cases, it is positive. So the post-Diwali air quality in almost all the metro cities, all the million plus cities of India, is on the negative side, is bad in a sense, is very, very bad, very, very unhealthy to that extent. Okay. Okay, now if I come to the 2019, if I come, because I said 2018 data is available in the post July months. So one analysis I did not perform for 2018, but 2019 you will see some further analysis. Okay, of course you can see, you can understand this is the 2019 NO2 level data, and same thing, it is 12 days average, 5 day on the left side, 5 day on the right side, and the 0 day. That is 11-day data. And this diagram again, it has got almost similar pattern, but it has got many cities there is a flat. No Diwali celebration 2019, or very little celebration. Even you can see some country, some cities have almost flat, like this city, almost flat. This city almost flat. So no firecrackers, has been celebrated in that city. So or the pollution level remain the same. So that is a beautiful presentation of the data in GIS platform. And okay, so if I analyze same thing, so mind it, in 2018 Jamshedpur was the highest polluting city, but in 2019 Diwali, the Diwali date was 20th of October, 27th October. In that case, the Ahmedabad was the most polluted city during the Diwali. And interestingly, you can see a good number of cities, good number of cities is here. that is Aurangabad, Nasik, Surat, Pune, Madurai, even Vijayawada. Now, of course, this Jabalpur. These are the cities. They are much below the national average. So this is beautiful, and we can say that that mm, COVID restrictions, COVID-related restrictions could lower the pollution level, and some of the cities, mind it, very interesting. Some of the cities are having much lower pollution level during Diwali in 2019. So that is really fun, fantastic, say mm, findings, and and we know there are. I mean, in 2021, last year, I have searched the literature in the month of March or somewhere, March or April. At that time, there were nearly 2 lakh publications, 2 lakh publications, global publications, stating the impact of COVID-19 on different sectors of environment, and air pollution is one of them. Many, every say university, every college has got at least one publications, more than one publications, on assessing the impact of COVID-related restrictions in lowering the atmospheric pollution. So this data also prove the same. So specifically, I have customized the timetable, time duration during the Diwali, so that 11-day window, and then also we can establish the same truth that yes, the Diwali could reduce the pollution amount in total, and of course some cities are much below the national average, but still there are some cities like Ahmedabad, Jamshedpur, Balinagar, and Delhi, Patna. They are well ahead, well above the national average in terms of ambient in during Diwali in 2019. Of course, this is the same diagram, you can understand, but lot of cities in compared to 2018, lot more cities having the negative changes. So the post Diwali pollution is lower than the pre Diwali ambient air quality. And now this is a fantastic study, and I don't know how many of you can appreciate this diagram, and try to appreciate this diagram, and I tell you, I'm working for this data generation. I don't know, Keshav, when you contact me, maybe in December,
Yes, sir. Yes,
and December. And since then, I am trying to make this particular figure, and I am so fortunate, I'm so lucky that this morning, yesterday night, when before sleeping, I'm going to bed around 12 midnight. So I could get the sense that yes, before the lecture time I can prepare this diagram. So this is a long, very hard working data output. Maybe you will see this is a simple diagram, but the background is very complex, and try to appreciate. So these are all the 43 million plus cities in the x-axis, in the lower axis. Okay, and each city, for example, this Ahmedabad has got 12 months. You see, January, February, March, April, all the 12 months of ambient air pollution. Average ambient NO2 during the month of January in Ahmedabad, February in Ahmedabad. So all the 43 cities has got an annual ambient NO2 level. Understand now this diagram? So maybe I could have shown you a single city. Yeah, this is a single city. This is a single city, and this is Agra in case of Agra. Just alphabetically, Agra is the first one. So just try to understand this, and I'll go back again to the diagram. So this is January 19, January, February to December. This is the annual monthly average of NO2 level at ambient air, outdoor air. So like, temperature curve, like precipitation curve in our climate, this Na2 is also having a annual fluctuation. It is not constant. It is not constantly same. So like the Diwali fluctuation, pre-Diwali, Diwali and post-Diwali fluctuations, it has also got monthly fluctuations. So irrespective of Diwali, if it is Diwali or not, it will change. There may be natural factors, because this year long in 2019, because 2018 data, whole year data, it is not available. That's why I could not show you. But you see, this red color, I put this red color specifically for your understanding. This is Diwali month. That is, the Diwali was on 27th of October. So whole October, I kept it in red color. I should leave this and remove, make this thing little above. Okay, you can, so that you can see it. Okay, so you can see now this Diwali month, see, very interesting. We attribute as like all the pollution of atmosphere, ambient atmosphere, is due to like this Diwali celebration. So whole the newspaper, whole the WhatsApp, Facebook, everyone, the new court, politicians, everyone behind this festival. Yeah, Diwali to galo. আমাদের সমস্ত সবাই আমরা এবার মরে যাব সব পলিউশনে, it's like that. But actually you see the average ambient NO2 level in air in the month of Diwali, of course it is little above the national average. This is national average. This line is national average, just that I have shown, and I said you to remember this line. I will be using this line repeatedly in many diagrams, many dialogue. This is the national average. Only the month of December is having lower than the national average, and all the other months is above the national average, and this Diwali month is much lower than the June or May or April. So the summer has got higher concentration of NO2 level in the air. You understand? Summer has got higher amount of concentration of NO2 in the ambient air, but not Diwali. So what I say, most of the newspapers, most of the journalists, most of the people, we talk about this diagram. We do not consider the whole, we do not have the holistic view. We just have a very narrow, very single, perception, single day events view. We do not look at the long term. We do not see the long term. If we see the long term, the whole picture is different. The whole picture is different. Just see, all the cities, almost all the cities throughout the year is having this line, this national average under their monthly average. Only a small portion, this is Tiruchirappalli. Most of the month it has got lower value, and some, of course, some southern states, as you have seen from the from this diagram, that southern part is much clean in terms of, say, NO2 pollution. Okay, so the Ahmedabad, I think this is how this diagram is made. This diagram is made maybe due to this highest value of NO2 in the month of October in 2019. So October is the Diwali month. So I kept October, arranged all the data based on the amount of, say, NO2 in October. In that case, average pollution of the ambient air in Ahmedabad in the month of October is poorest among rest of the country, rest of the million plus cities, and Aurangabad has the least amount of October is NO2 in the ambient air. So this is the Varanasi. If you see the Varanasi, I mean, I don't know how many times, 1, 2, 3, more than 3 times, higher than the national and Diwali pollution in most of the months. So Diwali, I mean the Varanasi, you can see Meerut, you can see Dhanbad, Allahabad. So which not? I mean, most of the cities have got, but I can see Delhi. People are always talking about the pollution in Delhi, pollution in Delhi, pollution in Delhi. But you see, Delhi is, of course, in terms of October pollution, it is in the fourth in the rank, but actually it is much less than the Varanasi air pollution. Okay, so this is a beautiful, say, I can say the contribution or say findings. I never read this kind of data. Most of the literature, they have only the Diwali or the COVID period. They don't look at the holistic kind of view. So you can understand this diagram. Now, this is what diagram. Yeah, top 5. This is top 5 polluted country, polluted city in 2019. So you can see the Dhanbad, Varanasi, Meerut, Allahabad, and Delhi. These are the top 5 polluting cities in 2019 in terms of NO2. And I have done this for their annual average. Okay. So you can see all the cities are much above the national average. Similarly, this 2020 diagram, and maybe we are closing to the end. And this is of course annual diagram. And same thing you can see the top 5 in the case of 2019. What were the top 5s? Were Dhanbad, Varanasi, and Meerut. Top 3: Dhanbad, Varanasi, and Meerut. And in case of 2020, it is Allahabad, Dhanbad, and Varanasi. So this has changed the rank. Yes, this has changed the rank. And what else? This is 2021 case. And same diagram. Annual NO2 level. And the top 5s again the Dhanbad, Meerut, and Delhi is much lower in 5th position. Ghaziabad coming in the next higher pollution level. So this is, as it is November, the data has been arranged based on the November data pollution. Okay, based on the November data, these cities are ranked accordingly. And again the same thing. And you can see if I this is the best part of the entire presentation, this diagram. Try to understand this diagram. All the cities are here. I mean, all the cities are here. All the 43 cities are here. And the first part is 2019, 2020, and 2021. And you can see 2019 and 2020, this green and red horizontal line is the national average during Diwali of NO2. And you can understand most of the cities having much higher, than the national average. And the national average is very close. 2020, 2021, this national average is very close. Very little difference in their concentration. But 2021 is having a little higher than the previous 2 years in terms of NO2 pollution in million plus cities. All the million plus cities are here. And from January 19 to December 2021, all these 36 months are mapped, or the diagram it is here before you for your understanding. Okay. So yes, one more thing. Maybe this is the final one of the final slides here. And if I see maybe if I show you the GIS, QGIS, we can download the data in QGIS. And if I see the whole India, that data looks like that. And of course, we can do the style of this data based on the color. Say, so you can understand that these red marks are more pollution. So far, this where we were discussing, these red marks were having higher pollution, and using a simple diagram. কোথায় চলে গেল রে আমার লাইনটা? You can understand the small line is going over there. I can draw, of course, I can draw. I can draw. No. Okay. So if I want to say plot a profile, if I want to plot a profile among the cities, so in GIS I can do this type of mapping like this. So you will appreciate I am drawing a cross section: Lucknow, Allahabad, Varanasi, Patna. Then I can come to Ranchi, Jamshedpur, and I can come to Kolkata. I can stop here. Oh my God. I can stop here, like I did something wrong. Maybe I can touch Delhi, Faridabad, Agra. What is that? Kanpur, Allahabad, Varanasi, Patna. I can come to Ranchi, Jamshedpur, Kolkata, and so this is the profile. I mean, NO2 profile. So not only topographic profile we can do, but GIS can help us to draw the atmospheric pollution profile too also. So this data from Google Earth, we can download it for our GIS analysis, and we can do whatever GIS we want to do. So this kind of profiling you can do. So it is showing the level of pollution. So if I skip it here, so it is showing the Kolkata. So Kolkata has got much higher pollution than its rural part. And similarly, this is what? This is Jamshedpur town. You see, it's a very high peak. And this is what? Varanasi. Now this is Delhi. So Delhi has got a very high peak, and rest from the rest of the areas. And of course, this is Diwali 22 image. So in that way, we can do this profiling, and what else? Nothing more. So I think I should stop here, and hope you have enjoyed the lecture. And yes, there are some questions I can understand in the chat box. Maybe I can take this chat box here. And okay, so maybe, is there any difference between light and electromagnetic radiation? Yeah, light is a part of the electromagnetic radiation. Okay, light is part of the electromagnetic radiation. Yeah, sir, our mobile camera is really camera or scanner? Huh? Very interesting question, Vicky Kundu. Mobile camera is a camera or scanner? I don't know what is the difference you want to know, but what I can say, nowadays all the digital camera, any camera, because I don't know if you have seen any real camera or not. Previously it was there. There was a film inside the camera, and light used to do chemical interaction on those films. But now all the digital camera records the amount of light in number. It records the amount of light, and it has many bands, RGB, red, green, and blue. So it records the data in these 3 bands and present as the DN value only. So digital camera and scanner are like Xerox machine, you can say. What the Xerox machine does, and our camera does the same thing. So it's a similar thing. Okay, Bapidas, which remote sensing is the best in sunlight, active or passive? Which remote sensing is best in sunlight, active or? I mean, you mean active or passive? Bapidas. Yeah, I mean, Bapidas, I don't know. The purpose is important. The active remote sensing is very difficult to, if I show you the active, because most of the data, what you have seen is processed. So if I show you the active, data, it is very difficult to distinguish the features in the active remote sensing images. So in the user's perspective, so like from our perspective, it is mm, active remote sensing is not very user friendly. It requires a lot of, say, intensive training and very high end computer. Ordinary our this computer cannot work with the active remote sensing data. So in that sense, I would say the passive remote sensing is more, useful to us and easy to understand, and it is 95% of the remote sensing devices are on this active remote sensing data. Okay, so what is the question, Bapidas? Is again Bapidas. Bapidas, is there any difference between geosynchronous? There, geosynchronous and geosynchronous, same thing, no difference. স্যার কোচবিহার ডিস্ট্রিক্টের একটা বাবার ইংরেজি বলতে বলতে বাংলা দীপঙ্কর কোচবিহার ডিস্ট্রিক্টের একটা স্যার ডেটা কিভাবে ডাউনলোড করে দেখিয়ে দেবেন প্লিজ দীপঙ্কর very nice, very honest, humble submission. Dear Dipankar, maybe we can sit, there is a app called AnyDesk. You install AnyDesk in your, Timokon has already left the meeting. But anyhow, if this question applies to anyone, so you can share your AnyDesk code. I can help you to, but in computer, in our ordinary computer, working with SAR data is really painful, because it requires at least 32 MB RAM. If your computer has 32 MB RAM, you can work with it. If it has less than 32 MB RAM, your computer will take overnight to download one single scene, so I do not use this computer for downloading the SAR data. And in our office has got a data limitation, so we do not so SAR data. Okay, sir, Krishna, is Krishna not made for climate monitoring? Krishna, I don't know, Biki. Maybe you can send me WhatsApp or email. I'd like to know about this, Krishna. Thank you so much. I will look for this data. Thanks.
Siliguri Municipal Corporation is actually 42.1 square kilometer. So in this small area, is it suitable to use Tropomi, sir? Tropomi data?
Yes, you can downscale it to 5-meter resolution.
Okay,
You can
okay,
download
okay,
the data up to 5-meter resolution. That is very interesting. Tropomi sensor, na? I
Yes,
said, during my presentation, I said there is no specific resolution, special resolution for this Tropomi data. You can just go for 250 meter, 1000 meter, 5000 meter to 5 meter, not less than 5 meter. But better to do it in 10 meter, because you have to correlate the data even with the land use and other data, right? So,
yes, sir.
so the Sentinel has only 10 meter resolution. So better to downscale it to 10 meters so that you can have other correlation property.
Thank you, sir.
Okay, welcome. Any more question? And no. Okay.
Participant to interact with Professor Biswas. So I think, sir, there is no question.
Okay.
Further, if they want to interact, they will surely contact you. So it was a very nice session, sir, and very enlightening presentation from your side. Hope the participants have enjoyed that. And now I would like to ask Keshav sir, did our principal sir is able to join the session?
Yes, Principal sir is already joined our meeting.
Okay. Then, so I would like to request our principal sir to say few words to our resource person, because I want to take apology from our side. At the beginning of the session, we can't maintain all the protocols to welcome him, to felicitate him, because we were busy in some technical issues were there, and we were a little bit busy in a meeting. So now we have all joined after 10 minutes after you started the presentation. So I beg apology from you, and I
No, no,
would
no, no.
request
Don't do that. Okay. It is not required, it is not required. We are all teachers. We all understand the official process, decorum, many issues that they are coming in between. So I enjoyed the lecture. So
yes, sir,
thank you so much for
we
giving
also
me the
the
opportunity.
presentation we also enjoyed. But I would like to request our honorable principal sir, Dr. Pankaj Kumar Debnath, to say few words to our resource person. Keshav, kindly contact with principal sir.
I think sir again, due to some technical reasons, sir again left the meeting. So okay,
So shall we wait?
yes, Sonel ma'am.
So shall we wait for him or we continue our session?
I think we will continue the session because already near about 2 hours past.
Okay. Sir, there is a request from a participant that please can you share the PPT, the presentation PPT of your with us? Then they will be very helpful and would come to know more.
No,
Uh,
actually PPT, PPT is some data and other thing. So it's really difficult. This is the first time, I could finish the data work in this afternoon. So
okay.
if it is published, then I can definitely share. But the methodology, they should understand the basic methodology that I have tried to explain.
Yes, yes, no
Sorry,
problem.
I'm
No
so
issue, sir.
sorry.
There was just a request from the
Mm.
participants. So
Okay.
I would now like to request our uh, head of the department, Keshav
Right.
Mondal, to convey the vote of thanks to Professor Biplab.
Thank you, Sonal ma'am, once again. So we are the just end. We are the last portion of our session. So again, I would like to thank my sincere gratitude to our principal sir for his uh, spontaneous support to organizing these types of national, even national, international, or these types of educational program. And I would like to my heartiest thanks to our resource persons, Professor Biplab Biswas, Burdwan University, for accepting our request to deliver such a interesting types of lecture. Actually, um, I am also working with this air pollution in Durgapur area. So it's also my very interesting for me. And I also share my thanks to all the participants, all the students, all the research scholar, and all the professors from different universities and colleges. I also I also uh, share my thanks to all the committee members. Actually, we are organize such types of special lecture. So in this lecture, uh, from different universities and colleges, students, special teachers, research scholars are join this lecture from Panchanwarma University, North Bengal University, Burdwan University, Jadavpur University, Raiganj University, Kumaon University, Nainital, Chandigarh University, Gwalior University, Uttarakhand, Vidisha, Pamgarh, Muzaffarpur, Gopeshpur, like these areas. So I again thanks to all of the members. Uh, okay, over to Sonel ma'am. Our principal is there, or Sonel ma'am, our principal is in our meeting.
No, no, Keshav sir. He is
Okay,
not there.
okay. Sorry, Biplab sir.
No,
Uh,
no, it's okay. No problem. Don't worry about it.
okay, sorry, sir. Actually, sir, I am also working the air pollution. Actually, spatio-temporal variation of air pollution and its impact on human health in Durgapur
Wow.
area. So that's why in future I like to solve some my query to you. So,
Sure,
sir,
sure.
in future, may I contact you?
Yes, of course. No problem, Keshav.
Yes, sir. Thank you very much.
No
Thank you, sir.
problem.
So today I end the session.
Okay.
Actually,
Thank you so much. I also
thank
thank all of you, for this nice organization, nice arrangement of the conference. I really appreciate all of you, all of your effort. Thank you again. Hope to
you,
see
sir.
you again near future.
Thank you, sir. One second. Thank you.
Bye bye.
Thank you, sir, and thank you all the participants. And so it's time to say goodbye and have a great day ahead. So
Thank
let's round up this session. And thank you, sir. We will be surely in touch in future.
you. Sure, sure. Thank you.
So one announce from organizer that the feedback link will be sent to your mail ID. That's why after receiving the mail, you can fill up the feedback form, and then certificate will generate and obviously send in your mail ID. Thank you to all of you, all the participants. Thank you, sir.
No,
Thank you.
sir, actually, we will give